what I was saying was that a current of 1 ampere means that a charge of 1 coulomb is carried over a duration of, a charge of 1 coulomb is carried in 1 second. Okay. Now, when I have a wire from A to B, as I've shown here, okay, and mark an arrow from A towards B and write 1 ampere, that means that a positive charge of 1 coulomb has gone from A to B in 1 second. Okay. Now, the exact same situation can be depicted by having a wire with an arrow drawn from B towards A and with minus 1 ampere marked on it. Okay. Now, this is something that you have to get comfortable with. You can depict the current, the same current, as positive 1 ampere going from this side to that side, or negative 1 ampere going from that side to this side. Now, the reason this is important, this looks rather trivial. The reason this is important is that when you solve for circuits, when you start solving a circuit, you don't know which way the currents are. Okay, you will assign some variables I and mark the directions of currents, and I could come out either positive or negative. And in later cases, we will see that it could even be time varying. Okay. Now, for you to interpret these results correctly, you should become very familiar with the convention. Okay. What I want to emphasize is that just because I have drawn an arrow from B to A doesn't mean that current is actually flowing in that direction. It could be the negative of that also. Okay. The value could come out either positive or negative. Okay. So that is about currents. So any questions, anything that is confusing about the definition of current and the convention of the sign? We will be talking about currents through wires. Okay. Okay, there were a few questions. First one was what is a coulomb? Okay, coulomb is the unit of charge. Okay, you perhaps know that electron has a charge of minus 1.6 times 10 to the minus 19 coulombs. Okay. So roughly speaking, you need 10 billion electrons to be flowing to have 1 ampere of current in 1 second. Okay. You should have 10 billion electrons flowing in 1 second to have 1 ampere of current. So that is the unit of charge. Now there was another question which was about the current flows only on the surface of the conductor or not. Now we will not worry about that. Okay. Now it turns out that at low frequencies current flows uniformly through the surface of the wire, and as you go to higher frequencies it tends to go towards the surface uniformly through the cross section of the wire at low frequencies, and as you go to higher frequencies it will be only towards the surface of the wire. But for us those details are not important at all. We will be looking at the total current flowing through the wire. Okay. Okay, and there was another question on flow of current through coils. Now, whether it's a coil or not, current will flow through the wire. Okay, now you're probably asking about what happens due to that current. there will be magnetic fields, but we will not be talking about it at this juncture. Okay, and someone else asked whether any random movement of electrons becomes a current. Yes, it does. Okay, in fact, electrons are moving randomly all the time, and there is a big field of study on noise, which is the electric current due to random movement of electrons. Okay, as long as the temperature is above absolute zero, this will keep happening. Now there was another question on the positive charge, why we take it that way. So this is something historical. I think historically people did experiments with electric currents on all kinds of things when it was not known that electrons are what carry current. Okay, so they just decided the direction of current as the direction of flow of positive charges, and it should also be noted that in certain chemical experiments it could be some positively charged ions that are actually flowing. Okay, when we have wires, it's only negatively charged electrons that are flowing, but that's not the case in every situation. So it's some arbitrary thing, and that is the historical convention, and we'll stick to that. Okay. Now there are also questions on AC and DC and so on. So those things we will not worry about. Okay, that is just has to do with how the current changes over time. Okay, so that's not something fundamental. And so that is about those things. And also for us, all conductors are perfect. Okay, so the conductor itself will not have any influence on the current. Okay, so this is an idealization, and many of the wires that we use, which are made of copper, come fairly close to this ideal level. Okay, so again, we will not worry about the effect of wires at this point. Okay, now let's